Well, hello one and all, and welcome to our short on pytest. Now, pytest is a module you can use to test your code more thoroughly than you could on your own. And I have here a program called convert.py, whose purpose is to convert this unit called an astronomical unit, often used in space exploration and so on, into a more friendly measurement called a meter. So I have here down below the convert function, and this does the following. It first checks if the argument AU is of type int or float, and if it is not, it raises, in this case, a type error for the wrong type. It says AU must be an int or float, in this case, if it is not. Otherwise, if AU is of type int or float, we'll go ahead and return the conversion between astronomical units and meters from this function convert. Now, I could go ahead and run Python of convert.py, and I could maybe test this on my own. I could type in maybe 1 for AU and get back, in this case, some large number of meters. I can go ahead and type Python of convert.py and get back, in this case, again, some large number of meters, but I could probably be more thorough than this. And I really hate to be the programmer to sit down and write these tests myself, just kind of hitting, Control L to clone my terminal, run this program again, type in some new input, and check the result by hand. So that's why things like pytest exist in the world. Now, if I want to write some tests for my code and do so with code itself, I can use, by convention, per pytest, a file called test underscore and then some given name. So I'll call this file test underscore convert.py to test, in this case, this function I have called convert. And again, by convention, in pytest, files that hold tests for our code, in this case, have to begin with test underscore. So I'll go ahead and open up code of test convert.py, and again, by convention, I'll go ahead and import this module called pytest. Now, what could I do? Well, I want to, in this case, test my convert function. In general, when we're using pytest, we're engaging in unit testing, testing individual units or functions in our program. So I'll save main for testing later on. I want to focus on convert right now. So I could go ahead and import the convert function from my convert file. I could type from convert, this file here, import the convert function. And now I can use the convert function inside of test convert.py. Well, here, again by convention, if I want to write some code to test convert, I should write it inside of a function that begins with test underscore. So maybe the simplest thing to test here is just some simple values, like the conversion between 1 AU and to meters instead. So I'll type def and then test underscore conversion here. And this is making for myself a new function that will run when I call pytest in my terminal. As we've seen before, pytest relies on this idea of asserting something to be true. And if it is not, pytest will let us know if our program has not behaved as we expect. So here, I could assert, let's say, that when I call convert and give it an input of 1, that should be equal to, in this case, this large number of meters. I'll go ahead and type this in here. 1495997870700. Let me double check this here. 1495997870700. So this is a large number of meters, but it is the conversion between 1 AU to meters. Now, a side note here is that if I was writing these tests, I'd probably want to be very sure this is the right conversion. And this is probably a good chance to say, like, if you were to type out, what is this, 1, 2, 3, 6, 9, almost 12 numbers here, just be doubly sure you're typing each of them right when you're writing tests like these. So here, I'll go ahead and run pytest now that I have, in this case, my test convert.py file. And when I run pytest in my terminal, it will look for a file like this, test underscore convert, or begins with test underscore, and it will then run all of the functions that begin with test underscore and let me know how many have passed and how many have, in this case, failed. So I'll go ahead and run pytest, and fingers crossed, we see that 1 has passed. In test convert.py, there is one little dot here, meaning this function did what it was supposed to do, not encounter any errors. Now, it's a good idea to think through other kinds of scenarios to test in your code. In this case, I'm converting 1 AU, but what are some other representative scenarios we could test? Maybe something like 50 AU as well, convert 50, which happens to be this other long string of numbers. So again, message here is maybe write your test so you get fewer numbers than this. 3, 5, 3, 5, 0, 0, 0. I'll double check this again. 7, 4, 7, 9, 8, 9, 3, 5, 3, 3, 5, 0, 0, 0. Great. All right, so this is the conversion between 50 AU to meters as well. I'll go ahead and run pytest again, and fingers crossed, we see that, again, those tests have passed. And notice here, it still says 1 passed down below, 1 passed. We count, in this case, by the function. But in this case, these two individual tests have to both pass for this test to be considered passing as well. Now, we could think of other kinds of scenarios to test. In this case, negative numbers, maybe 0 as well. Things like that are really useful for testing your code here, but more on unit testing in lecture. We'll focus here mostly on pytest. So here, what else could we do? Well, we've seen that in convert.py, I have, in this case, not just the pathway of returning the actual conversion, but also this pathway of raising a type error. And it's, again, a good idea to test all these pathways through our functions. So we could ideally try to test, does convert raise a type error when given an input of the wrong type? Well, thanks to pytest, we can actually do this. I'll go ahead and go back to test convert. And let's go ahead and try to add in this case, a new test, one that tests for the proper error being raised. I'll call this one test error. And again, we'll make sure this begins with test underscore. I can then use what's called a context manager with here to go ahead and try to run convert and expect, let's say, that I get a type error in particular. So by convention, or with the syntax of pytest, I could type with pytest.raises type error, colon, and indented inside of this with block, I'll type convert, and maybe give as input quote 1, just like this. So this now means that if I were to call convert and give as input 1, quote unquote, well, I would expect a type error to be raised. So slightly different syntax from what we see on lines 7 and 8, but the same kind of semantics. We expect whatever we run inside of this block here will raise a type error. I'll go ahead and run python of convert.py, or just pytest. I'll hit pytest here, and now we'll see that 2 tests have passed. So not just test conversion, but also test error as well. So it seems like convert does raise a type error when given, in this case, an argument that is not an int or a float. Now, there's still more to test. In fact, up here, I was really just testing whole numbers, 1 and 50, but it's worth thinking of floats as a special case when we're testing. In particular, this is because of floating point imprecision. So you've probably heard that there are only a certain number of bits we can use to represent certain numbers in code. In fact, in Python, maybe you have anywhere between 16 bits to 32 bits to 64 bits, but however many number of bits we have, we're always going to have some finite number of bits to represent numbers. But when it comes to floats, there's actually an infinite number of floating point values out in the real world, any number of real numbers. And so at some point, we actually can't represent decimals completely precisely. And so when testing them, when testing inputs and outputs, testing floats in particular, we have to make room for something called tolerance or approximation, some bit of wiggle room to say that, yes, this value here is 1.00000001, but it's close enough to 1 that we'll consider it as 1. So let's go ahead and try and see what kind of utilities pytest has for those kinds of scenarios. I'll go ahead and look at a new test here, one called def test float conversion. And for consistency, I'll say this is testing our integer conversion between whole numbers and whole numbers, but this here is testing our float conversion. In here, I'll try to assert that I will be able to convert 0.001, a pretty small float itself, to some value like this, 149597870.691. Double check this here, 149597870.691. So here, I'm essentially saying I expect that 0.001, when given as input to convert, will be equal to this particular floating point value here. But this might not always be the case, depending on the level of precision I'm expecting. So if I want to allow for some kind of tolerance, let's say I'll accept, this number 0.69000001 as also a valid equivalency here, I can use pytest.approx, and give as input the value I'm hoping to compare. And this will use pytest's sensible defaults to allow for some tolerance when testing the equivalency of these two floating point values, both from the return value of convert and this one I've written over here. So if I run pytest, again, I'll see that 3 of these tests have passed, which seems pretty good here. But let's play around a little bit with the actual tolerance that approx gives us here. I could, if I wanted to, change the tolerance, maybe make it tighter or a little looser. Now, if I wanted to allow any value plus or minus, let's say, 0.1, I could type this, abs equals 0.1. And this means that if convert 0.001 returns to me this number plus or minus 0.1, I'll accept it as being equal to this particular number here. So a bit of tolerance we've given ourselves here. I'll go ahead and run pytest, and we'll see that that seems to have passed. But let's see how tight we can make this tolerance before we get into some trouble. I might type something like this, maybe 1e negative 5, let's say. So this is the same as writing 1 times 10 to the negative 5th. A very, very small tolerance here. I'll go ahead and say pytest, and so we seem to have gotten an error. It looks like comparison failed. We see here that the actual result obtained from convert 0.001 was this number here, which is not within the range of our expected value plus or minus 1.0 times 10 to the negative 5th. So if we loosen our tolerance a little bit, I could do 1e negative 4, pytest again. Even that doesn't seem to work quite as well as we want it to. What if I do 1e negative 3? Fingers crossed. Even that doesn't seem to do. 1e negative 2. That seems to be OK. So lesson learned here is that you can actually adjust these tolerances to be exactly the way you want them to be. And what I mean by that here is that if I were actually willing to accept this tolerance, this would be great. But I might be writing some scientific application, like maybe one for space exploration and so on, in which case a tolerance of 1e negative 2 is really not going to cut it. And so if I were to make this maybe 1e, let's say negative 12, for instance, a much more strict tolerance, and I see that this test doesn't pass, well, I should probably do something in my code to make sure that I get a value within this particular tolerance. So you probably shouldn't do what I had just done here, which is adjust the tolerance until you get the passing test. You should probably set your tolerance first and then make sure your code is giving you the right value you're hoping for here. In this case, I'll leave this alone. I'll say for now that a 1e negative 2 tolerance is sufficient enough for me here, but in the future, I want to make this a little bit stricter. So here we've seen various features of pytest. We've seen how to do simple asserts and testing for equality. We've seen how in this case we can test for raising certain errors, exceptions, and so on. And we've also seen how we can test conversion, how we can actually go ahead and compare floating point values using pytest.approx. This was our short on pytest. We'll see you next time.